Alright, I saw some really good stuff with these problems. For the first one, we had y equals 3x squared minus 6x plus 2. So the a value is 3, the b value is negative 6, the c value is 2. Now there's the vertex formula, so there's my work for solving for x. And then I plugged it back in to solve for y. Now the first thing that I saw that some people were doing is right here, where it's 3 times 1 squared minus 6 times 1 plus 2. People always tend to want to do 3 times 1 first and then square it to get 9. However, our order of operations says that we have to do the exponents first, then we can multiply. If it helps, you can always rewrite this problem to 3 times 1 times 1, because that's what 1 squared would equal. Now, if I were to have 3 times 1 times 1, that's obviously 3. So if this exponent is messing with you, maybe rewrite it so that you don't have the exponent. And just to clarify what I mean, if 1 squared is 1 times 1, then therefore 3 times 1 squared is 3 times 1 times 1. And so I get the vertex of 1, negative 1, and then I'm going to plug in points that are equal distance away. So people are doing a really good job with this. If my vertex is right here at 1, a point above is 2, and a point below is 0. And then 2 points below is negative 1, and 2 points above is 3. So now that I know that I'm symmetrical, if I plug in 2, I should get the same answer as if I plug in 0, which the output would be 2. And then for negative 1 and 3, I get 11. Now, I just jumped into this and made the assumption that I was right, and I'm pretty confident with my vertex. Now, here's the disclaimer, here's the warning. If this vertex were to be wrong to begin with, and you just blindly assume that these are symmetrical, they won't be because the vertex was not correct. So make sure this vertex is correct before you go and make these assumptions that these are symmetrical. If you're nervous about your work, just plug everything in and you should be getting symmetrical points. And that's my poor excuse for a parabola right there. So it's very hard to draw these types of parabolas when they're so elongated. This multiplier out front, 3, is our dilation, which means that it's 3 times as stretched. So you guys are doing great. Some of you, your parabolas look so much better than this one. Others, try not to draw them with your eyes closed. Now for the next one, the fraction. Now I did this one on purpose because half of the quadratics that you could graph have an odd b value. Now these are a bit of a pain, but we have a way to simplify it. So there's my work for finding x, and then I went through and I did out every single step so we could really see the y. Now 3 halves squared is 9 fourths, 3 times 3 halves is 9 halves, plus 1. Common denominators, combine. Common denominators, combine. So I get negative 5 fourths. Now when I show you my table, notice how I only have fractions in my vertex. That's because I'm using the same concept that I did up here of picking x values that are equal distance away from the vertex. So if this is going to be 1.5, if I subtract half a unit and add half a unit, I have 2 points that are the same distance away from this x value. If I subtract 1.5 units and add 1.5 units, 0 and 3 are the same distance away from the vertex. And so now when I plug in 0, 1, 2, and 3, you'll see I'm getting a lot nicer answers than those of you that were trying to plug in more decimals or more fractions. There's no reason to make this harder than it is. Yes, you did need to do the work for this middle vertex, but we can avoid future fractions and decimals by just choosing a value we like that is equal distance away. Now this one was nice because it was right in the middle. If I know that these are symmetrical and this one isn't a fraction, but maybe this one is, I still don't have to plug it in because this answer should be that answer. But we're not going to get into that because, we're remote learning and I'm not going to try to complicate things more than we have to. My graph, a lot easier to draw. I like the ones that are kind of squished like this one. and it just makes it a little bit easier to have that nice curve. Also, please try not to come to a point. This one's really hard not to do it, but it's really important that it's curved. A point would look like an absolute value function. So hopefully this helps out. I'll be giving some feedback online, getting grades up to date, and also there's a project posted for you guys. So take a look. You're doing great. I'll talk to you later.